Hello everyone, I'm your teacher for this question. The question says the given function is not one-to-one. Find a way to restrict the domain so that the function is one-to-one. Then find the inverse of the function with that domain. We're given the function f(x) is equal to square root of 4x minus x squared. Okay, so first of all, we need to know what is a one-to-one function. For a one-to-one function, there are three conditions. First is 1x corresponds to 1y. Oh, this 1, okay. And the same for y. 1y corresponds to 1x. The second rule is you should pass the horizontal line test. Last one is if f(x), if the function is continuous, it must be strictly increasing, so it goes up, or strictly decreasing. Okay, so either goes up or goes down. All right, that's what it means. Okay, now let's look back to the question. So we're given this function right here, f(x) is equal to square root of 4x minus x squared. So if we look at the graphical representation, it should be something that looks like this. So let me draw the axis. So that's y and this x-axis. Let me use another color for the graph. We have a thing that goes up first and goes down, semicircle. And it passes through 2 points, 0 and 4. And the coordinate right here is 2, x coordinate, okay? And this is the turning point. All right, so if we look at the question, we can find the reason that y is not one-to-one. Though 1x does corresponds to 1y for this function, it's not strictly increasing or strictly decreasing because it goes up first, then it goes down. So it does not fit the description. And if we look at the domain, so first of all, we can start with the domain. We know that from the graph, we know it's from 0 to 4, but algebraically, we know that 4x minus x squared has to be greater or equal to 0. And this can also give us 0 to 4 for the x. Okay, so this is the domain. The way we restrict the domain so that the function is one-to-one is we can set it to be strictly increasing. So we restrict, oh, not strict, restrict, okay. Restrict the domain to be 0 to 2, let's say. So from 0 to the top point or turning point of 0 to 2. So it's increasing, strictly increasing, okay, goes up. And the way we find the function is like this. So let me write this. So we have, let's say yx is equal to, is the same as y, then we write it as 4x minus x squared is equal to y. Then we should have 4x minus x squared is equal to y squared. So cancel the square root sign. And then we make it as x squared minus 4x. So we put a negative sign in front of everything, and this is the result. Next, very important, complete the square on the left side. we should get x minus 2 squared minus 4. So this is the same as x squared minus 4x plus 4. So that's why we minus 4 to get the original function. Okay, so we complete the square, and the right side is still negative 4 and yx squared. Then we move the negative 4 or move the minus 4 to the right. We get x minus 2 squared is equal to negative y squared plus 4. This is the same as 4 minus y squared. And then we take the square root. We should be equal to x minus 2 is equal to square root of 4 minus 1 squared. Only use the upper part. We only use the positive part. Okay, so that's why we don't write the negative sign right here. And then we move the 2 to the right. We get x is equal to 4 minus y squared plus 2. Last step is to find the inverse of the function with this domain. Very simple. We just switch x and y, and we should get y is equal to 4 minus x squared plus 2. This is the function we're looking for the inverse of the function with this domain. Okay, so x is in the domain of 0 to 2 and is strictly increasing in this domain, in this interval. Okay, so what we can take away from this question is first the definition of one-to-one function, and then we can check if a function is one-to-one based on these conditions, and we can also restrict the domain of the function to let it be one-to-one. Okay, so that's all for this question. See you in the next video.